Lesson 1-7, Functions. Essential question. How do you evaluate an equation written in function notation? The vocab word for this lesson is function notation, which looks like this. The way that you say that is f of x. So what function notation means is that every equation written in function notation is a function. All right, so if I'm given two functions, 3x squared and 4x minus 5, I need to plug different values in to figure out what my answer is. Now keep in mind, function notation doesn't always have to be f of x. You'll notice in this one we've got one equation that's f of x and one equation that's g of x. Those are still both in function notation. And if you graphed 3x squared or 4x minus 5, for example, you would end up with a function. So if I need to find f of 4, that means I need to plug 4 into my f equation. So I'm not going to do anything with the g equation right now. I'm just going to put it into my f equation. So I'm going to rewrite f of 4 equals. Now what I'm going to do is that you'll notice that instead of this x here, we have a 4. So that means wherever I see x in my equation, I'm going to plug a 4. So rather than writing 3x squared, like the equation says, I'm going to replace that with the x with a 4. So really all I've done from my original equation to my new equation is replaced x with a 4. Now I have to simplify this. Now we have to go back to using PEMDAS before we can do 3 times 4 squared. So keep in mind, PEMDAS tells us to do our exponents before we multiply. So I have to do 4 squared before I times anything by 3. So 4 squared is 16. And then I just have to do 3 times 16. So you can either use a calculator if you don't have one. We'd end up with 48. So 48 is my answer. All right, second one, g of negative 2. Now this time, since we have a g in front, I'm going to use my g equation. So I'm going to write g of negative 2 equals. And then instead of writing 4x minus 5, I'm going to replace the x with a negative 2. So rather than writing this x, I put a negative 2 in my equation. So again, I'll do PEMDAS. 4 times negative 2 is negative 8. Negative 8 minus 5 is negative 13. So 4 times negative 2 is negative 8, and a negative 5 make a negative 13. All right, f of negative 3. So now I'm going to go back to the f equation again. So I'm going to go back to the 3x squared. So my f of x is 3x squared, so that's the equation I'm going to use. So f of negative 3. And then instead of putting 3x squared, I'm going to do 3 times negative 3 squared. So again, I'm replacing x with negative 3. I have to do my exponents before I multiply. So negative 3 squared is the same as negative 3 times negative 3, which is positive 9. 3 times 9 is 27. And g of 1. So I'm going to go back to my 4x minus 5 equation. Instead of an x, I'm going to put a 1. 4 times 1 is 4. 4 minus 5 is negative 1. All right, now I've got two more equations written in function notation. They're just slightly different than the ones on the last slide. This time I've got 4x squared and 5x minus 3. So I'm going to do the exact same thing, f of negative 1. So that means I'm going to take negative 1, and instead of having an x, the negative 1 goes in for the x. So right here. So negative 1 is being, or x is being replaced with negative 1. So 4 times negative 1 squared. Negative 1 squared is the same as negative 1 times negative 1, which is 1. So I've got 4 times 1, which is 4. G of 4. So x is being replaced with a 4. So I'm going to put that 4 right there. Five times 4 is 20. 20 minus 3 is 17. F of 2. Go to my f equation, which is f of x equals 4x squared. Replace the x with a 2. 2 squared is 4. 4 times 4 is 16. And g of negative 5. Replace x with negative 5, so 5 times negative 5 minus 3. 5 times negative 5 is negative 25. Negative 25 and negative 3 make negative 28. Now we're going to get to some that are a little bit trickier. So rather than just one number in the parenthesis, we're going to have a variable and either an addition or subtraction sign. So this problem's got m plus 5. So f of m plus 5 equals, so now I'm going to take m plus 5 and plug it in for my x. So rather than just one number like we plugged in on the last two slides, we're going to plug in m plus 5. So now it's not just 3 times a number, it's 3 times m plus 5 plus 2. So whenever I see a number outside of a parenthesis, I have to distribute first. So 3 times m is 3m. 3 times 5 is 15 plus 2. Now I've got 3 terms, but 2 of my terms are alike. 3m doesn't have anything to group with, but 15 and 2 are like terms, so I can add them together to make 17. G of t plus 1. So I'm going to take t plus 1, and instead of putting the x there, I'm going to put it in for the x. So 2 times t plus 1 minus 1. I've got a number outside of my parentheses, so I distribute. So 2t plus 2 minus 1. If I do my underlining, 2t is by itself. 2 minus 1 is 1. 2t plus 1 is my answer. and g of p minus 2. So I'll replace x with p minus 2 in my g equation. So 2 times p minus 2 minus 1, distribute 2p minus 4 minus 1, underline, negative 4 and negative 1 make negative 5. So 2p minus 5. All right, function notation. Find the answer and drag it. So what we're going to do for each one of these is we're going to plug the number that it gives us in for x. So rather than f of x, we have f of negative 2. So I'm going to replace x with negative 2. So 3 times negative 2 squared. Well, negative 2 squared, negative 2 times negative 2 is 4. 3 times 4 is sorry, I forgot the plus 4 at the end. 3 times 4 plus 4, 12 plus 4 would give us 16. So then I'm going to bring the 16 over here. Okay, second one, find f of 8. So I'm going to plug 8 in for x. So negative 5 times 8 plus 2 would be negative 40 plus 2, which equals negative 38. Find f of 1. So 8 minus 12 times 1 would be 8 minus 12, which equals negative 4. Find f of 5. So 5 squared minus 5 equals 25 minus 5, which equals 20. 2 left. F of negative 15. Negative 15 plus 8 is negative 7. And f of 2. So 2 to the third power minus 4. Now remember, 2 to the third is the same as 2 times 2 times 2, which gives me 8. So 8 minus 4 equals 4. Summary. To evaluate an equation in function notation,